so we should be good to go here. All right, so we got Unit 2, Lesson 7. All right. So what we're dealing with mostly in this unit, or this section, is we're dealing with area and volume of prisms. Since we're talking about volume, we know that what type of figures do we have? 3D, yeah, with three-dimensional figures. Okay, so we're talking about three-dimensional figures. Okay, a prism is a three-dimensional object which has two bases or ends that have a small size and shape and are parallel to one another. So you can have a lot of prisms. So if you have a triangle and a triangle, and they're connected by lines, that's a prism. Okay, if you have an octagon and an octagon, and they're connected by lines, that's a prism. That's what that means. Any shape, okay, whoops. Okay, any shape, like I'll see if I can attempt to draw one. Something like that. Okay, that's a prism. Okay, you have a triangular prism. Okay, and no judging, no judging. Okay, and you can do any type of shape like that, and that creates a prism, what their point is. So you have a right triangular prism, which is a right triangle on top. Right rectangular prism, that just means a box. And then a cube is just a box that's all the same size. Yeah, exactly. Okay, and here's those pictures, which are much better than me attempting to draw them. Okay, a volume of a prism is just the area of the base times the height. It's a very simple thing, but the area of the base can change. So you can talk about your triangles, your rectangles, okay, or your cubes. All right? So that will just help you kind of get through that. Okay, then here's your formulas, the other ones you may need to remember. So perimeter of circle is also called what? Circumference. 2 pi r, or pi times diameter, would be your circumference or stuff around the circle. We're on 166. Just sorry, gotta get the new guy in there. Sorry. Come on, Chris. What kind of new friend are you? Okay. All right. So any questions on circles? And then the area of a circle is pi r squared. So that's right here. Okay. Area of a triangle, half base times height. That's why I'm not going over these all the way. Okay. Trapezoid. Okay. So what this means is what the a plus b is. Trapezoid has two bases. It has a small one and the big one. Okay. You take the trapezoid's bases, you add them and average them. That's what you're doing. You're adding one plus like small plus big and dividing it by 2, timesing it by the height. That's how the trapezoid's formula works, but again, that's there for you. We know rectangle, we know square. Parallelogram is still base times height because it's just a rectangle shifted. Okay, let's see how we can do on this one here. All right, so consider the right triangular prism shown. Determine the area of the base of the prism. So let's turn the area of the base. All right, so this is 13. This is 10. So what am I missing? The height. So what do these ticks mean? That means they're equals. That means this is 5, and this is 5, and 13. This is 13 right here. So then how are we going to figure out the other side? Pythagorean theorem. Okay, I'm going to go 5 squared plus x squared equals 13 squared. This is actually a very common Pythagorean triple. I don't know if you've seen it, but it's going to be 12, but I'll show you. Okay, so you're going to have 25, 169 minus x squared equals 144. X squared equals 144, and x equals 12. So our height is 12. If I went way too fast there, sorry, I thought you guys did that already before. Have you done that yet? Okay. That's why I kind of went fast. So just what I did was I just solved for x. 5 squared is 25. I minus it over. 13 squared is 169. That leaves me that x squared equals 144, and then square root. So that gives me 12 here. So now we have everything we need to do the area of our base. The area of our base is going to be 1/2 times 10 times 12. The base is 10. The height is 12. Okay, that's going to give you 60. Okay, so the area of the base is 60. That's all it asked me to do in part A. Yeah. Oh, I'm sorry. Okay, and determine the volume of the prism. So what do we do to find the volume? It's the base times the height. The height is 6. So 6 times 60, 360 centimeters cubed for volume. That's how you label it. Yes? Yep. Okay, determine the surface area of the prism. That takes a little bit more time because you have pieces. But the good news about prisms is you have 2 of the triangles. We already found that area, didn't we? It's 60, so we have 2 of those. 60 plus 60 is my 2 triangles. And then I have 1, 2, 3 rectangles. I have the face here, and the backside face. And they're all easy to find because they're just rectangles. This one is 10 times 6, so that's 60 again. 13 times 6, which is 78. And then the back side, what's this length? Is it 13 too? Okay. So 13 times 6 again, so another 78. Okay, then we add all those up. We'll get 336. And this is squared. We're dealing with surface area, you're dealing with squared. Okay, good deal. All right, so some more just kind of zipping through another chart here. Okay, so the table below just shows common units. Okay, so metric just tells you centimeters, meters, cubed. When you find that stuff, the imperial, inches, feet, yards, that stuff. Okay, do not worry about this because we're not doing cubic conversion, so don't worry about that. All right, let's see, we want to do this here. Okay, I'm going to skip this one. All right, so surface area and volume of right cylinders. Okay, so surface area is 2 circles plus the wraparound. The best way I always kind of show this, and I've showed it a few times, you can take a piece of paper, you can roll it, so it's like it's a cylinder now. And if I cut that, it rolls out to being a rectangle. So this part right here I call the wraparound of your cylinder. You have your circles and the wraparound. So what you have to understand is this, like it's telling you, is the circumference. Okay, that side's the circumference, this side's the height. Because we know that rectangles are length times width. Well, this one's height is, you can call it the width, and then the length is the circumference. Okay, so area of a circle, pi r squared. This right here would be height times circumference, or you can put the 2 pi r. And then the area of the circle is pi r squared. So you add these 3 things for the surface area. So what about for the volume? What would you for the volume? Well, just what we just did for the prisms, the base times the height. You'll take the area of the circle, and then so just for volume would be pi r squared times height, times your height. That'll get you the whole volume of the whole cylinder. Okay. We just kind of answer the questions below. So this right here is a surface area cylinder. 2 pi r squares, what's this P stand for? The 2 circles. That's the 2 areas of circles. And then 2 pi r h is the wraparound. That's the surface area of the cylinder. And then the volume, like we just said, is simply area of a circle times the height of the cylinder for your volume. Remember, this will be in cubic units. This one will be in square units. Okay, and again, we just came up with those formulas, and they give you these formulas like it's kind of redundant. And we're on to our last page. It's the good news. All right, so let's do these other examples in this last page together. And like I said, I want you guys to have some time to work today. Okay, so Calculate the volume and surface area of cylindrical can whose height is 15.4 centimeters and whose base diameter is 10.2 centimeters. Write your answer to the correct one decimal place. So I have my calculator on me. Somebody's going to have to help me out here with the calculations, but we'll set it up. So we know that we have a can or whatever, okay, and we know that its height is 15.4, and then we know that the diameter all the way across is 10.2, or we can call it our radius is half of that, which is 5.1. Okay, so if we're setting up our surface area, okay, so Tatum, how would I set up my surface area? What do you think? You can look at the formula if you want. 2 times area of the circle. Okay, 2 times area of the circle, which is pi r squared, which is 5.1 squared, plus what? The wraparound, which is the circumference times the height. So plus 15.4 times the circumference, 2 pi r, which is 5.1. So here's your calculation set up. So let's walk through that one more time. 2 pi r squared, that's the two circles, top and bottom. Height times wraparound, the circumference. This makes the whole wraparound, excuse me. Okay, somebody calculate that for me. And then we'll start volume. Make sure you use your parentheses. Anybody brave enough to say? Yep, 656.9 centimeters squared. Remember, squared because it's surface area, just the surface. It's not something you can fill. It's not three-dimensional. Now, the area inside the can, the volume, Alex, how would I set that up? Pi r squared times height. Okay, and what's that going to be? Got that one, Chris? Good. 1,258.4 centimeters what? Cubed. Cubed. Good. All right. Two more examples. Okay. Commercial garbage bin in the shape of a cube has a volume of 60.24. Determine the dimensions of the garbage bin to the nearest tenth. So a commercial garbage has its dimensions of a cube. So that means the length, width, and height, they're all what? The same. So what do we have to do to 60.24? Cube root it. Good. You have to cube root it. You can do that on your calculator. Okay? Because we know that a cube is, the volume of a cube is side times side times side, which is side cubed. If the side cube we give us a volume is 60.24, my way to do algebra is to cube root both sides. Okay, so the side length would be what? Yeah. You hit math, and it should be like your third or fourth option. Okay. What did we get? Should be like 3 point something or 3 point what? Sorry. 92. Thank you. 3.92. Okay. But it says, do you guys pay attention to the labeling up there? It says the nearest centimeter. It gives me in meters. So we just figured out the side in meters. So how many spots do I move by decimal for centimeters? What? Times 100, or I move it over 2 spots. Yes. That works, okay? So We know it's 3.92 times 10 to the second, which, like Joe said, is 100. So then I'm going to have 392 centimeters is what each length of my cubic garbage can is. Kind of weird to have a cubic garbage can. Okay. So if they want you to write the dimensions, you can be redundant and write like that if you'd like. And it's going to be where? This? Yeah. Yeah. Side. Okay. All right. B says the box for the Toblerone chocolate bar is in the shape of a triangular prism. The triangular faces have a base of 3.7 and the height of 3.2. So you're talking about that really long. I don't know if you have seen these, but they're candy bars that are really long. Okay, so it says the height is 3.2 for the height, and then the base is 3.7. Okay. It says if the space is in an empty box has a volume of 123.7 to determine the length. So that's what it's doing. It's giving us pieces of information except for the length, so we don't know the length. Okay? But we do know how to find the volume, right? Our volume of a triangular prism is base times height. The area of that base is what? This base here is a triangle, right? So what's that going to be? How do you find the area of a triangle? It's half of a square divided by 2. Base times height divided by 2. So I have 3.7 times 3.2 all over 2. That's dividing it all by 2. Times length equals volume. But they give me volume. They say the volume is 123. So let's do this calculation here. What's 3.7 times 3.2 divided by 2? 5.92. So I have, this is what I have. I have 5.92 L, which we're solving for, equals 123.7. Is everybody with me? Because why do I have an L there? Because L is my missing length. I'm trying to figure this out. That's the goal of the problem. So now there's algebra. How do I get rid of 5.92? Divide. Okay. And when you do that, I believe I got 20.9. Does anybody have anything different? .9 centimeters. Okay, good deal. All right, last one. You guys have a lot of time today. That's good. Oops. All right, poster company has decided that all of its posters will be shipped in cylindrical containers with a height of 17 inches and a circumference of 2 inches. Okay, the curved surface area of the container will be wrapped with a paper label containing the company logo. Calculate the nearest square inch the curved surface area for the wrapping of the container. So think about that in terms of realistic terms. What are we not wrapping? In terms of that cylindrical, what are we not wrapping? We're not wrapping the circles. So are you okay with adjusting your formula to taking out the area of the circles? So we know that it's usually 2 pi r squared plus 2 pi r h, right? But all we need to wrap this cylindrical container, we don't need this. We only need the wraparound. Kind of suits the name, huh? So, but what we have to do is, by the information they gave us, they gave us the height. So we have height. We have height. That's 17. But then it gives me the circumference. Okay, now, do I need to break down and solve for r? No, that gives me the circumference, right? What does this piece represent? The circumference. 2 pi r is the circumference. So if the circumference is 2, then I can say 2 pi r equals 2. That's what I can do with that. So essentially, all we have to do is just go, and it seems like this looked really hard, all we're doing is 17 times 2, 34 inches squared. So every container needs 34 inches squared of that paper or the logo wrapper. Okay? All right.